In this video lecture, we will talk about solubility of solids in liquids. And the most common example of solid that gets dissolved in water is common salt or sodium chloride that gets dissolved in water, right? So when we add sodium chloride to water, right? Sodium chloride, as you keep adding sodium chloride to water, sodium chloride will keep dissolving in water, right? And the process of adding this sodium chloride to water, we call it as dissolution, right? And as you keep adding sodium chloride to water, the concentration of sodium chloride will keep increasing in water, right? The solution will become more concentrated, right? And as you keep adding sodium chloride, you will notice that at one point the sodium chloride will stop dissolving in water, right? And at that point you can see some solid sodium chloride that will get dissolved at the bottom, right? So at this point, when no more of sodium chloride could dissolve in water, we know that we call it a saturated solution at this point, right? And the maximum amount of solute, right? The maximum amount of solute dissolved that gets dissolved, right, in water at the constant temperature, right, that is known as its solubility in water, right? So saturated solution is when sodium chloride will stop dissolving in water, right? At that point we have saturated solution, right? And the maximum amount of sodium chloride that is there in solution at that point, that you call it a solubility of sodium chloride in it, right? And the solution before reaching its saturation point is unsaturated, right? And we are already aware of these things from our previous classes also, about the definition of solutions and what are saturated solution, what are unsaturated solution, right? So now let's discuss about factors that affect the solubility of solid in a liquid, right? And we are aware of one thing, right, that ionic compounds like sodium chloride is soluble in water because it breaks up into ions, right, in water, right? Due to the presence of ions, sodium chloride is soluble in water, right? Now we'll see the detail of breaking up of sodium chloride into sodium and chloride ions, right? And how water will function, right, to keep this sodium chloride to dissolve in, to keep sodium chloride in dissolved state in water, right? So some factors that affect the solubility of solid in a liquid is, the first thing is nature of solute in solvent, right? And one thing we are aware of, that like dissolves like. When we say like dissolves like, we mean that polar solute will dissolve in polar solvent and non-polar solute will dissolve in non-polar solvent. Example, like sodium chloride, which is considered to be a highly polar solute, will dissolve in water, which is a polar solvent, we know, right? Because water is a dipole. The water molecules exist as dipoles, right, which are considered as polar in nature. Similarly, if we talk about non-polar solute and solvent, is solution of benzene in carbon tetrachloride, right? It's an example of non-polar solute in non-polar solvent, right? So let's understand one thing, that what is the basic condition, or what is the most important thing that decides the solubility of any solute in a solvent, right? Suppose we have A is your solvent, right, and B is your solute, right? So when we have, let's suppose this is A, we are adding it to B. B is your solvent, right? And when A mixes up with B, it will form AB, right? It will form AB. So how many types of interactions do we have in this solution that consist of A, B, right? So they would be, we have solvent in it, right? so AA interactions would be there. We have solute in it, so BB interaction would be there. And since A mixes up with B, so we have a third kind of interaction, which is AB, right? And now for any solute to dissolve in a solvent, this AB interaction should be maximum, right? Then only this solute B will get dissolved in A, right? And if you just imagine this, when it forms this AB, what B is doing, B is replacing, right, some A molecules, right, and it will form AB, right? So here, when the interactions between AB, right, when the interaction between AA and BB is almost similar, right, then only this B would be able to replace A to form AB, right? And then only these two solutions will mix up, or we say then only the solute will dissolve in the solvent when AB interactions are maximum, right? That is what we say is when B, which is solute, would be able to interact with A, molecules of solvent A, right? Then only, since if these solute molecules, B molecules, would be able to interact with A molecules, then only B, right, which is a solute, would be able to interact with solvent, which is A, right, to form AB, right? So these interactions should be maximum for a solute to get dissolved in the solvent, right? So now we said that sodium chloride dissolves in water, right, because it forms ions. It forms ions in water. Just remember this, right? So here, if we go by this interaction between water, there would be interaction between water and NaCl, right? So for this NaCl to dissolve in water, this water and NaCl interaction should be maximum, or we say solute will get dissolved in solvent when solute solvent interaction is maximum, right? So solute will get dissolved when solute solvent interaction is maximum, right? Now we'll just see this interaction of solute with the solvent in detail, right? So before that, just let's look at one thing. We say that sodium chloride, which is a polar solute, does not dissolve in non-polar solvent which is carbon tetrachloride. Why? Because we say that it does not form ions in carbon tetrachloride, and so it does not dissolve in carbon tetrachloride, right? We know that carbon tetrachloride, right, these molecules are held together by weak van der Waals forces, right? Whereas sodium chloride is held together by strong electrostatic attractions, right, due to sodium and chloride ions, right? So these sodium chloride, right, sodium chloride would not be able to interact with carbon tetrachloride, which is a solvent, because the force of attraction between sodium chloride is very high, right? It's so high that it would not be able to interact with CCl4 interaction, which is weak, right? And we have already studied here in this explanation that interaction between solute and solvent should be maximum, right? So here between CCl4 molecules we have weak van der Waals forces, and between sodium chloride molecules we have strong electrostatic force of attraction, right? So the interactions are very different, right? So sodium chloride molecule would not be able to interact with carbon tetrachloride molecules like it can interact with other sodium chloride molecules, right, strongly. And we know that carbon tetrachloride molecule is not polar, right, and it does not have charges, plus minus charges, that can interact with sodium chloride, right, because sodium chloride has plus minus charges and it can interact strongly only with those solvents that has plus minus charges, that is only with polar solvents. Since carbon tetrachloride does not have polarities, does not have positive and negative charges, so sodium chloride would not be able to interact with carbon tetrachloride, right? So this AB, right, solute solvent interaction is very weak. So carbon tetrachloride would not be able to dissolve sodium chloride in it, right? Now let's discuss this in detail. When sodium chloride gets dissolved in water, what actually happens is, we know that if we just talk about the crystal structure of sodium chloride, this is how sodium chloride looks like, right? Its crystal lattice is like this. It has plus minus, right, plus minus, minus, plus minus, right, plus. So it has positive and negative ions which are held together by high electrostatic force of attraction, right? So in order to dissolve this sodium chloride in water or in any solvent, the solvent should be able to break this crystal lattice, right? If solvent is successful in breaking this crystal lattice of sodium chloride or of any other ionic compound, then only that solvent would be able to dissolve this ionic compound or sodium chloride in it. In this example we have considered sodium chloride and water, right? So now let's see how water will break this crystal lattice, right, and will dissolve sodium chloride in it, right? We know that water has this kind of structure, right, where it has positive charge and slight positive charges on hydrogen atoms, right, and slight negative charge on oxygen, right? Oxygen has high electronegativity, so it has slight negative charge, and electronegativity of hydrogen is less, so it has slight positive charge, right? So interaction between solvent and solute, you could imagine that what we have discussed here, this is polar, right? This has plus and minus sign, this has plus and minus sign, right? So plus of solvent would be able to interact with minus, right, minus of this salt, and minus of solvent would be able to interact with plus of solute, right? So we saw that interaction between solute and solvent is high, right? AB is high, or it's almost same as between sodium chloride and between water molecules. So sodium chloride would be able to dissolve in water. So now let's see what it does. These ions which are in the middle or which are deep inside this crystal lattice, these are all surrounded by other oppositely charged ions, right? So the ions which are at this boundary, right, the outer boundary or this boundary, right, is little exposed, right? There are no ions here at this side to save these ions, right? And these ions, right, these ions and these ions would be attacked by a water molecule. So now let's see how will it attack. just remember that I said plus of this will interact with minus of this, and minus of this will interact with plus of this, right? So now let's see how water molecule would be able to break this lattice, and when it will break this lattice, it will pull these positive and negative ions, which are represented by plus and minus signs. We know that plus is sodium ion and minus is chloride ions, right? So now let's see how water would be able to pull these sodium and chloride ions from this crystal lattice, resulting into the breakage, resulting into the dissociation or breakage of this crystal lattice, right? So this is negative, right? This is positive, right? So this hydrogen ions will pull these negative ions, right, out of this crystal lattice, and these negative ions will pull out these positive ions, right, from this crystal lattice. And this is how water will pull out these ions and bring into the solvent, water, right? Solvent, which is water, right? So if you just imagine this in a container, this is water, right? This is water. Water will pull these ions, sodium and chloride ions, in water, right? It will break this crystal lattice, and like this you will see sodium and chloride ions in water, in this beaker that contains water, right? When sodium chloride gets dissolved in water, right? So now let's see, when water will pull these ions in water, what will happen next. So when these ions are pulled, we know that water is dipolar in nature. That means it has two poles, positive pole and negative pole, right? So when it will pull sodium ions in water, after it pulls sodium ions in water, water will surround these sodium ions, right? The negative end of water molecule will surround the positive ions of water molecules, right? Similarly, if you talk about chloride ions would also be pulled by these hydrogen atoms, positive hydrogen atoms. So chloride ions would be surrounded by positive end of water molecule, right? This process where water molecules surround these oppositely charged ions is known as solvation of ions, right? This is known as solvation of ions. Since we are using water here, so it's hydration. We call it as hydration of ions. And how do we define it? Hydration of ions is where water molecules surround the oppositely charged ions, right? Now let's see more into it. So when water molecule will surround these oppositely charged ions, since negative end of water molecule is surrounding the positive ion, so this negative end will neutralize or lessen the charge that is on the positive ion. Similarly, the positive end of water will reduce or neutralize the charge on this chloride ion, right? Since sodium